Start off with in solving this out is I'm going to say let's state that y equals to the natural log of x. Okay, that is my original equation. Y equals the natural log of x. And I want to know what the derivative of that is. But before I do that, I can't just go in and do that now because I don't know this. So I'm going to take both sides and turn them into exponents with e as the base.
Is that a y?
Yeah, this is e to the y equals e to the natural log of x. And if you want to make me cringe, call that ln of x. It's just the natural log of x. Okay, now, e to the x and the natural log of x, these are inverse functions of each other. Which means if you take a function and you compose it with its inverse, and they're in terms of x, the result will be x. So if I compose e to the x with natural log of x, the end result is x. So I got that x equals to e to the y. All right, now I get to this point right here. Now I want to take the derivative of this. Okay, what's the derivative of x? 1, yeah. Now, what is the derivative of e to the y? Well, we just got finished looking at that. The derivative of e to the y is y prime. So it's going to be e to the y times y prime. Does this make sense?
Yes.
Okay. Well, that's what I want to know. I want to know what y prime is. If y is equal to the natural log of x, I want to know what y prime is. So y prime is going to equal to 1 over e to the y. That's just cross multiplying right there. I'm taking this e to the y right here, pulling it down here by cross multiplying. Or I'm dividing both sides by e to the y, however you want to look at it. Now, how are we given equations? We're given equations with respect to x, right? So what is e to the y? Well, we said right here that e to the y is x. So y prime is going to be 1 over x.
That's pretty cool.
Good deal. Yeah. So again, let's go into the form that we talked about earlier. Let's say we want to know what the derivative of the natural log of u is. Well, it's going to be 1 over u times the derivative of u.
Because of that.
Yes. Remember, it starts off, x is right here, right? So whatever you're taking the natural log of, that's what ends up in the denominator. Are we good to keep going?
When we write our natural log, do we have to do the L and the N in cursive?
No.
Okay.
If I don't, it looks like one N. So I do it in cursive for that reason.
Your cursive looks great.
Thank you. You're my favorite student sitting in that desk right now. Okay. So let's do the derivative of the natural log of, I don't know, let's say 3x squared. Okay? Well, what do we know that that's going to equal to? What's in the place of u here?
3x squared. So
3x
it's gonna
squared.
equal 1 over 3x squared times whatever the derivative of 3x squared is, and that would be 6x, right?
Times 6x, yes. So simplifying that out, that's 6x over 3x squared, right?
Yeah.
Now 6 over 3 is 2,
2.
and x over x squared, so we get 2 over x. When we reduce it. A lot of times these natural log problems will reduce down to very tiny numbers, which if you need to go in and take the second derivative of the number, which means you're taking the derivative of the derivative, you've got something usually pretty easy to work with. How y'all feel about that?
As long as we remember the, like, E and U, and the natural log of U, and like that formula, we go to those derivatives.
Yes. Yes. Okay. Let me let y'all do one on your own. Let's take the derivative of the natural log of sine of x. This is one of my favorites. Yes.
What happened to this? Well, is it that you multiply 3 times 2 and then divide it by 6, but I don't know.
From here to here? Or
From
here to here?
yeah, the second one.
Yeah. 6 over 3 is 2,
Yeah.
and x squared divided by x is x to the negative first, which just puts it in the denominator.
Oh.
You good?
Yeah.
Okay.
Oh, yeah, cause it's cosine for some, sine of
Cosecant times cosine is cotangent, right? We're wrong.
Cosecant times what?
Cosine.
Times cosine?
Yeah, cosine.
This is 1 over sine.
Yeah, that's gonna be 1 over sine times cosine, which would be cotangent, yeah. And I'm sorry, I got lazy. I get mad at people that don't do that, and then there I am not doing that. You gotta have an angle defined with the trig function. Okay.
So are these like new shortcuts?
Well, I don't know that it's necessarily a shortcut as much as it is we don't know how to deal with the natural log of x as a derivative until we find out what the derivative is. So it's not really a shortcut in yeah, it is a shortcut because I wouldn't want to set up the limit as h approaches 0 of the natural log of x plus h minus the natural log of x all over h. I don't know that I'm smart enough to do that. Can I erase this? Okay. This is my favorite proof of natural log of x, and because I mean we just learned e, so since we know how to handle e, we know how to handle the rest of it. The last thing we're going to look at is just an exponential function, such as, let's say that we have y equals 2 raised to the x power. Now, what this is not, you don't pull down the x, does not equal to, okay, we got x and then it's times 2 to the x minus 1 power. That is not what's happening here. Remember how we verified the power rule was that we used binomials to break it down. This does not lead to the binomial expansion. So that does not work here. So let's just consider, not necessarily the natural log of, or 2 to the x, but let's just consider that we have y equals some value b and it's raised to the x power. Well, from here, I'm gonna take the natural log of both sides. So I'm gonna say the natural log of y equals to the natural log of b raised to the x power. Again, no calculus. That's just what I've done. Can't tell if it's recording or not, I hope it is. All right, now there's a rule with this that says I can pull this to the front. That's just the power rule with logarithms. But I'm going to rewrite this as the natural log of b times x. All right. Now I'm ready to take the derivative. Now, the natural log of y, when I take the derivative of that, that is 1 over y times y prime. Right? Now, what is the derivative of the natural log of b to the x power? Well, we got to consider what b is. B is just a constant. Like, in this case, it was 2. So, the natural log of 2 is a constant. It's an irrational constant, but it's a constant. So if I take the derivative of this, it's just like me saying 2x, the derivative of 2x is 2, well, the derivative of the natural log of bx is just the natural log of b. And I'm wanting to know what the derivative is, so I'm wanting to solve for y prime. So y prime is equal to y times the natural log of b. But once again, you're given these terms, or you're given these equations in terms of x. So because y is the same thing as b to the x, y prime is going to be b to the x times the natural log of b. And that's the derivative of an exponential function. So the derivative of y equals 2 to the x is 2 to the x times the natural log of 2. Are we okay with that?
Is that in simplest form?
Yeah, that's the simplest form.
Wouldn't the product, not product, the power rule work again for that?
Because the power rule does not work, because the way we proved the power rule was our base was our variable and the exponent was our constant. And it's flipped here. But where we proved that is we proved that using binomial expansion. We're not expanding that out in this case. So, are we good here? So let's do another example. Let's say we have y equals 7 to the x power. Well, what's y prime going to be? 7 to the x times the natural log of 7. All right, what about y equals pi raised to the x power? Y prime equals pi to the x times the natural log of pi. All right, now what about y equals e to the x? E is just like pi, it's an irrational constant. Say that again. E to the x times the natural log of e. Okay. So what just happened here? what did we say earlier that the derivative of e to the x was? E to the x, right? But what did I get right here?
Does that mean
Is
that,
it not one?
is that,
Say that again, Ship.
Natural log of e is just one.
The natural log of e is 1. So this is the same thing as e to the x times 1, which is just e to the
You
x.
wrote out one.
yeah,
Huh?
One.
for a second.
You thought I was going to write 1 to O and e?
No, it looks like you already
Like
wrote
the
it.
natural log of e looks like
It's
one
all
spelled
N-E.
out. Because of your cursive L.
I thought you said my cursive was neat earlier.
No, no, it does. It's just like
I gotta go see if I can find some detention slips. Well, it's a natural log of e. Sorry that my handwriting did that to you.
No. It's like a joke. Like, you know, like e to the x with your natural log of
It's
e
funny
looks like
'cause the
1, so
natural log
e.
of e is 1, and it looks like you wrote one.
So it's like
I've got to see this from a different perspective. No, I'm still not seeing it, but
You don't
I'm,
see the O?
I don't see the O, I see an L. But anyway, we're good. Okay, so basically d dx of b to the x, or b to the u, is b to the u times u prime times the natural log of u. Bless you. So if I say y is equal to 3 to the 2x power, y prime would be 3 to the 2x power times 2 times the natural log of 3.
So the natural log of b and
Thank you. Natural log of b. It helps when I write the formula down. Correct. Natural log of b. All righty.